Okay, hi, grade nines. Now we're on to question 8 on page 319. I believe in your homework, I marked you as doing A and C. So I think I will do, you know what, I'm going to do both. I'll do both of these quickly, okay? So I'll just sort of divide the paper in half here. And actually, I'm going to start with letter D first. And the reason I'm starting with letter D is because I like that this is written with sort of the denominators where they are. It kind of, I don't know, it helps my eyeballs look at this from a cross multiplying point of view. I'll show you what I mean here. Okay, so you got 7 over 6, 2, 5 minus g all over 3. Okay, so like I hinted at, I want to cross multiply. Now, the reason I want to cross multiply is because that's my coping technique to get rid of denominators. If I can avoid having denominators in my algebra equations or expressions, I'll do it. I'll try to avoid it. And one neat little trick of getting rid of denominators is to cross multiply across an equal sign. All right. Make sure you have an equal sign, by the way. Sometimes I see students try to cross multiply on the same side of an expression, and that doesn't work. You need an equal sign. The 3 travels all the way across an equal sign, crosses over to the left side from the right, and you get 3 times 7, and that's equal to 21. Okay? Now over here, something interesting happens, all right? All right, I'm just going to just change colors here for a sec. Let's go with, let's go with green. Okay, so when I cross multiply that 6, actually that color is not that much different, so I'll switch to orange. When I cross multiply with the 6, okay, here's how you want to write it. Here's one way I write it, and there's kind of no one perfect way of writing this, but what essentially is happening is let's start with the inside of the brackets. You have this expression of 5 minus g, and whatever that works out to be, I don't know what g is yet, and I'm not concerned about that right now. But I have the expression of 5 minus g, and whatever this expression would happen to work out to be, once I found out what g is, whatever this expression is, I've got double this expression, all right? The 5 minus g, I know with the 2 outside, I've got double it. And then when I cross multiply a 6, it kind of works like this, okay? So what you're going to do is, I like to use the square brackets. I think sometimes people call them braces or something. I'm not an expert on the conventions of grammar. So anyways, I'm going to double bracket this thing, one with the round brackets and one with the square brackets. All right. Now, what happens is you distribute the 6 to the 2, and that's it. In other words, it's the 6 and the 2 that have a cross multiplying relationship. The 5 minus g in this bracketed expression, this sort of binomial, it's kind of protected from the cross multiplying. Like, it's just sitting here waiting to decide, listen, in the end, are you going to be doubling our expression, or are you going to be, in other words, multiplying by 12? And the answer is you're going to be multiplying by 12. That's how you do it. Okay? That's how you do it. If you wanted to see how this worked out, well, let me finish this, and then maybe I'll show you a different way. So we have 21 is equal to 12 times 5 minus 12g. So you have 12 times 5. 12 times 5 is 60. 12 times a negative g is negative 12g. Okay, well, this is a positive, so the opposite of positive is negative. We're going to subtract a negative from both sides. Okay, so this zeroes itself out, and you've got negative 12g over here. And over here, 21 minus 60. Well, 21 minus 60 is the same as 61 minus 20, but you know what the answer is going to be. You know the answer has got to be a negative, right? This negative is way bigger than this positive. Okay, so I'm just reversing so I can subtract the smaller from the bigger, but I know the answer is going to be negative. I know it's going to be negative. So if it were 60 minus 20, that'd be 40. So it's 21. So it's going to be 39, negative 39. Okay, so let me just write that up here. Negative 39 is equal to negative 12g. All right, let's divide both sides by negative 12. All right. Whatever you do to one side, you do to the other. That's math teacher's favorite broken record expression. Whatever you do to one side, you do to the other. especially teaching algebra. A negative divided by a negative is a positive, and so what are you left with? Negative 39, sorry, positive 39 over positive 12. Now, you can change this. Well, first of all, you can reduce this. 3 goes into both here. That's supposed to be a division sign. And you get 39 divided by 3 is 13. 12 divided by 3 is 4. 4 into 13 goes 3 times with a remainder of 1. Okay? So I'd be happy with this answer, and I'd be happy with this answer. Okay? Let's go to question B. All right? Now, B is very similar to D, to be honest with you. In other words, look at what is similar, okay? This had a fraction on the left, and this starts with a fraction on the left as well. This does, even though it looks different, they both have fractions on the right. So let me show you what that means, okay? Let me show you a different way. So first, I'll just copy the question as is, but you can do a little rewrite. So this is what I would do. Because it's tough to see the cross multiplying. Some students are like, well, there's a 1/3 in front. And so what's going on with the binomial here? Like, does this have a denominator and is it a 1? And then how do I deal with that, right? But here's an inside trick. Here's a little hack, okay? You can rewrite this fraction in a different style. You can just write it like this. X minus 2 all over 3. In other words, you can extend this fraction line and make the 3 truly like a big common denominator. I'm just going to make that 3 a little bit bigger. Okay. So now, similar to here, remember how we cross multiplied? Well, we're going to cross multiply again. Okay. Cross multiply. So you got 5 times 2. Sorry, that's not true. 5 times 3. And that's equal to 2 times 1 bracket. So, I'm saying to you that this had a 1 outside in front, and now it's going to be multiplied by the 2. So let's deal with the left because that's a fairly straightforward thing. You got 15. And then 2 times 1 is 2. And you've got x minus 2 in brackets. So 15 is equal to 2x. Now we're going to distribute 2x minus 4. Okay? I did that fairly quickly, but I just want to say that, these two questions are fairly related. Okay? They're fairly, close. The only thing that's really different is this fraction looks different from this fraction. And other than that, though, really, fraction on the left, fraction on the right, you got a variable inside the brackets. It's pretty similar. Okay, so we've got subtract 4 from both sides. You got to deal with the constant first. And so you're going to add 4 to both sides. Boy, the 4s are driving me crazy today. You're going to add 4 to both sides and you get 19. 19 is equal to 2x. Divide both sides by 2. Okay. Look, when you get down to this one step, this second last step, I assume you guys know what you're doing. And if you don't, that's fine. You can ask me questions. One thing I don't want you to do, though, is get to the second last step and then make a mistake, right? But I tend to go faster in grade 9 than, say, I would in grade 8. Because you grade 9s are more experienced, right? You generally know what to do when you get down to these last steps. I think the hardest part for grade 9s is this part here. Okay, so you got 19 halves, which in itself is a good answer. I guess if you want to convert it, this would be 9.5 is equal to x, right? And then I know some of you get a little bit obsessed with decimals, and so that would be, I guess, a correct answer as well. But we've been trying to tell you, Ms. Schreiner and I, if the original question is in fractions, leave it in fractions. All right. Okay, I think that's all I want to say. Oh, one last thing. So let me just sort of tie this all together. I could have made question D look like question B. So let me reverse rewrite question D to look like question B, and I'll do it in pink here, okay? So I'm just going to just make some room there. Okay, you know what? This question could have been written like this. 7/6 is equal to 2/3, and then wrote it like this, 5 minus G. See? Like I could have made question D resemble question B, or I can take question B and make it look like question D. So I just, this is one way, as what I'm saying to you, grade 9, this is one way of writing a fraction, and this is another way. I always press the wrong button on this pen. This is another way. I slightly prefer this way because it sets up the cross multiplying. So I kind of prefer questions to be written this way. There's nothing wrong with writing it this way. It's the same thing. Okay, it's the same style. It means the same thing. Okay, guys, I'll keep going. That's it for question 8. See ya.